Infinity times 0. What do you do whenever you see infinity times 0? What? Take one and drop it. Exactly. Which one looks like the better one to drop? The x. Okay? So watch how I write. Notice I'm not going to get lazy in my writing. Natural log y equals limit x goes to infinity. I'm going to leave the natural log of 1 plus 1 over x. But then on the bottom, I'm dropping the x, which means it's a 1 over x on the bottom. Now, I'm going to just double check this. What is the numerator going to? So 1 over x goes to 0, right? That goes to 0. Can you all even see that dot moving? Barely. That goes to 0, plus 1, that goes to 1. Natural log of 1 is 0, right? Okay. Now on the bottom, fixed over infinity goes to 0. So now we have 0 over 0. L'Hopital. So we went from this crazy form, which was, where was the beginning of this? It was 1 to the infinity. We said, okay, make an equation. Natural log both sides. Pull that power out. Now we have infinity times 0. Okay, good. We can drop 1. Now we have 0 over 0. Good. L'Hopital. So the way we write this is as follows. Natural log y equals, with L'Hopital, limit x goes to infinity. Now I have to do the derivative of the top and the derivative of the bottom separately. So what's the derivative of natural log of junk? So 1 over the junk times, now the derivative of the junk, right? What's derivative of 1? 0. What's the derivative of 1 over x? Negative 1 over x squared. Very good. Right? That's x to the negative 1. 1 over x is x to the negative 1. Derivative of that is negative 1 x to the negative 2. That's negative 1 over x squared. So you remember how I told everyone here should know the derivative of square root of x is 1 over 2 root x? Everyone here should know the derivative of 1 over x is negative 1 over x squared. It just comes up a lot. That's just the derivative of the top, right? Over the derivative of the bottom. What's the derivative of the bottom? Negative 1 over x squared again. Hot damn, that's beautiful, because what happens? They cancel. That's great. That's great. You'll have that written down? I'm not done with the problem, but I got to go to a new page. Any questions? I feel like you're burnt out. Oops. What the hell? Why can't I get a new page? Oh, I ran out of paper. My computer ran out of paper. That's not a good thing. That means I've gone past. It's weird. Okay, so here's where I am. Natural log y equals limit x was going to infinity. The only thing left was a 1 over 1 plus 1 over x, right? Everything else canceled? Let x go to infinity now. What do you get? One over 1, which is 1. So here's what we're saying, folks. The natural log of y equals this limit, but that equals 1. So our answer is 1? No. What did I say in the very beginning? What's y? It's like I'm asking you what, in the very beginning I'm asking you what y is, and you're telling me what natural log of y is. That's not what I asked for. So how do you get y out of natural log? E on both sides. Good. So now I'm just going to take e on both sides. the e and the natural log will kill each other off. That's why I'm using it. So I get y equals what? E to the 1, which is just e. So the answer is e. So in summary, if I write down limit, well, I'll write it backwards. I'll put my answer first. E equals the limit as x goes to infinity, 1 plus 1 over x to the x. Really cool. So there's like, remember I told you all about that e to the pi I plus 1 equals 0. Did I show you all that? Did I show you? No? Sorry, wrong semester. I'm thinking up here. I never showed you all that? Maybe I did and it's gone already. That's argued to be one of the most beautiful equations in math. No? E to the pi I plus 1 equals 0. Widely considered one of the most beautiful equations in math. The reason is because it contains all of the most important numbers in math. 0, which everyone doesn't really think is a big deal. But remember how I told you, like, next to everything is a hidden 0? You can always add and subtract something. I told you that was a pretty high-level thought there. So 0 is an important thing. 1 is an important thing. Obviously, 1 is important now. I, the imaginary unit, that I up there, I is the square root of -1. Pi is the ratio of a circle's circumference to its diameter. And then e, which is the base of the log function that is special because the e function is its own is the only function that is its only is the only function that its derivative is itself. Okay, but the definition of e is this. Like, you know how e is approximately 2.718 blah blah blah. Anyone who has a calculator, you don't have to do this now, but if you're interested, just take some numbers for x and plug them in. Like take 10 and plug it in. And don't worry about the limit here. Just do 1 plus 1 over 10 to the 10. And then do 1 plus 1 over 100 to the 100. And then get bigger and bigger numbers. And I promise you, the further you go out, the bigger your x gets, the closer you get to e. E is approximately 2.718, but e goes forever. Never stops, never terminates, never repeats. So if you want to know what e is that. E is if you could go forever, that's e. Kind of interesting concept. How many of you kind of recall this formula from college algebra? You may have seen this. This is a formula for compound interest, okay? And what they said was this. They said, look, R is your interest rate, okay? T is the time, how long you're going to leave the money in the bank. And N, hold on, I messed up the formula. It's N down here. And N is the number of times they compound the interest per year. So like if you put your money in a bank and they say, okay, we're going to give you 2%, that's really high, but 2% for your money, and we'll compound the interest monthly. What that means is that they take your money and they cut it into 12 pieces, and every month they give you interest on a 12th. Then the next month, an interest on that. If you compound it daily, they take your money, they cut it into 160 or 365 pieces or whatever, and they give you interest on that piece every day. Well, what if you could cut your money up into an infinite number of pieces and give you interest on it every instant in time? Well, that would mean let n go to infinity here. Let the number of times you cut it up and the number of times you compound it go to infinity. And guess what that friggin' looks like? 1 plus 1 over x to the x, right? Replacing this n with x's. You get that, don't you? So a lot of you learn this formula right after you learn that one, PERT. And all PERT is letting n go to infinity in that formula. And when you let n go to infinity, you basically turn it into e. But that's beyond the scope of this class. I just wanted to show you it's used all the time. Okay? That limit is used, and whenever you use that limit, it basically turns it into e. All right. I think do you feel like done? Do y'all feel done? Maybe, man, what do y'all want to do? Well, 15 minutes, right? That's all we have? Yeah, that's good. I think we're done. Let's review back what our homework is. It's a lot of work right there. That's what, like 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, maybe like 30 or 40 problems right there. It's a lot of work. So, enjoy. Do y'all want to have a quiz next time, beginning of class, or? Sure. See, the thing is, the quizzes help you if you're ready for them. If you're not ready for them, but the thing is, you have to think about what your grades are on your quiz right now, because we're in week 5. We only have what, like 2 more weeks after this, or 3, right? So we're running out of quiz chances. The quizzes are what, like 20 or 30% of your grade? 30 to 30. So if you stick with what you've got as quizzes, it could really hurt you. So you might want to actually be asking for quizzes at this point, because the more you have, the more maybe I can drop 1, maybe 2. You know what I'm saying? So let's plan on a quiz beginning of class over these problems. I'll just do something similar to what's in there. Don't come in here like, oh man. He's right here. Your quiz will cover 1 problem from each section. 1 from 3.3, 1 from 3.7.
I was wondering if I could get 3 and 4.
Chapter 3 and 4, yeah. Let me turn off my camera first.